So children, now let us start with the fifth question. This is really important one. With this particular question, I would like to discuss the concept behind this, which was not discussed in your materials. I'm sure about that. So have a close look at this. Okay. So first of all, identify the chapter. Before that, it's better take a pause, read the question at least 2 to 3 times. Isn't it? So assume that the earth is a solid sphere. Okay, we know that earth is a solid sphere. So the important part here is that a tunnel is dug along its diameter. This is what is important. So a tunnel is dug, okay, along the diameter of that one. So have you read this kind of concept? Then what is the formula for the time period? So these are the 2 questions will reach your brain, isn't it? Now let me tell you. First I'll tell you the concept, right? So earth is in the shape of a sphere. Okay, let me take like this. Now a tunnel has been dug along its diameter. Clear? Now, I have to find out the time period of motion of the particle now. So how to find out that? So before finding that, first of all, I have to find out the mass inside this, because you people know that mass on the surface of earth is not equal to mass inside the earth or mass at a depth. So if the mass changes, then acceleration due to gravity also changes. So first of all, you have to find those things. Okay. So in order to find those things, let me assume that there is some point x inside or at a depth from the surface like this. X. So x is nothing but at a depth from the surface of earth. There is a point P, the distance of the point P at a depth x from surface of earth. Now, so it is sphere, no? So earth is in the shape of a sphere, no? So it comes under what? 3-dimensional. Now in 3-dimensional, what we know is that density is same always. So density inside the surface of the earth is equal to density on the surface of the earth. So density, what kind of density here it is? Volumetric mass density. So density is equal to mass by volume. So I could rewrite this as mass inside by volume inside is equal to mass on the surface of earth by volume on the surface of earth. Like this I could write. Okay. Now let us continue with this. Mass inside by volume inside is equal to mass on the surface by volume on the surface. Now mass inside I don't know, but volume inside, what is the formula? Since it is sphere, I could rewrite it as 4/3 pi into distance cube. What is here? Distance here, x. Okay. Now mass on the surface is m. Now volume on the surface. Volume on the surface, what I could do here it is 4/3 pi into radius of the earth, that is r. Radius is r. Okay. So this 4/3 pi and this 4/3 pi is cancelled. So mass inside by x cube is equal to m by capital R cube. So mass inside is equal to m into capital M into x cube by capital R cube. So like this we will get mass inside the surface of earth. Okay. So that's what I am telling you. Mass on the surface is not equal to mass inside. Okay. Our mass will changes. Now coming to the g value. G on the surface of earth is g only. But at a depth d it is changing, no? So how? So g, what, or you can write gravitational field. Anything, no problem. Okay. So if you write the gravitational field inside, then what is the formula? What is the formula? Okay. G m inside by x square. Children, so we know that gravitational field numerically equal to acceleration due to gravity. Numerically, that is E mod of this gravitational field equal to mod of g, isn't it? So here we know what is m in, mass inside the earth. So let me substitute that. G m in is nothing but mx square by r cube, which was divided by x square. Okay. So I have substituted the value of this m inside. So here what happens is that since here it is x cube, the square and here cube has been cancelled. So gmx by r cube. So this is what is the gravitational field intensity inside the earth. So numerically this E equal to g. So I could write this as g in also, okay, or acceleration. Could write in any way. So once we get this, we know what is this acceleration in terms of omega. So you people know that A equal to omega square into x, because up to the point distance. Now omega square x equal to g capital M x by r cube. From this, what happens is that we could cancel out x and x. So omega is equal to gm by r cube, and here you will get root because I have shifted the square to other side. So now still, you people know that this g on the surface of earth can be written as gm by r square, isn't it? This is from our basics. So here this gm by r cube can be written as g by r omega. So what is omega here? 2 pi by capital T is equal to root of g by r. Now why don't you reverse this? That is T by 2 pi equal to root of r by g. From this, the time period T is equal to 2 pi root over r by g. So children, now I told you the concept behind this question also. Concept behind this. So in order to solve this question, we have to know this derivation. Okay. Exclusive for tunnel case. So wherever you find tunnel, you can use this formula. Clear? If any changes are there, we could make some changes. Those changes we could identify and we could substitute in this derivation. So finally we can get the new answer also. So anyway we can use it. Now time period T equal to 2 pi root over r by g. So he is asking us to calculate the time period. Okay. Now let us start with that. So we got time period T is equal to 2 pi root over r by g. Look at the given data. R is nothing but radius of earth, which was given that 6400 kilometer. 1 kilometer is equal to 1000 meters, that is 10 to the power of 3. 6400 into 10 to the power of 3, whereas the value of g is 10. So here this will cancel like this. So now what I get here is that 2 pi root over 6400 into 10 square. So root of 6400 is 80 and 10 square is 10. So which is equal to 2 pi. This is the way I'll get. So final answer is 2 pi into 800. Okay. So this is nothing but in seconds. I want this to be in minutes. So 2 pi into 800 seconds must be divided by 60, so that your answer will be in minutes. So this cancel. Okay. So here 2 3s are 6 cancel. So pi is nothing but 3.14, but here 3 is there. So what you do? Don't waste your time simply. So 3 and 3.4 nearly both are same, right? So why don't you cancel this and find out the answer that is nearer to this one? That is better way. So they can save some time. So finally got it as 80 minutes. So 80 minutes is nothing but how much? 60 minutes plus 20 minutes. 60 minutes is 1 hour. Okay. So 80 minutes is nothing but 60 plus 20 minutes. So 60 minutes here it is 1 hour. So with this analysis I will get 1 hour 20 minutes. But this is approximate analysis because pi is 3.14, but I have taken 3 and cancelled because I don't want to waste the time. Now look at the answer that I got and just observe the options. Check the options. So 1 hour 20 minutes, where it is there? Second option. 1 hour 24 minutes. Okay. So there is no other answer near to this one. So here what I say is that option 2 is correct. Option 2 is correct. Okay. So like this, we should not waste our time for simple cases. We could do it. So with this, we have done our 5th question, my dear children. I have given you the concept behind this as well as the numerical part, solution. Okay. So now next, move on to the next one.